importance of CC and CE in amplifier circuits. This is the topic. Keep the heading importance of CC and CE. Importance of CC and CE. बहुत interesting topic है. Carefully listen करो. थोड़ा concentrate करो topic में. If you don't understand this topic, again the total subject will be disturbed by you. Okay? पूरा subject disturb हो जाएगा. See here. एक case start करना. Importance of CC and CE. First, suppose I started from biasing class. See the complete story I'll teach you. What is happening? Here, I have taken a biasing circuit. This is RE, and we have RC resistor, and we have some divider here, R1 and R2. This is R1, this is R2. We have here supply VCC. I started my amplifier circuit design like this. First DC circuit start here. Understand, okay? Understand how an amplifier will be designed. Story क्या है दिखाता हूँ. First biasing circuit design करना. क्या है sir? Biasing circuit से what you will get? What you are going to get biasing circuit means. इधर देखो biasing circuits में क्या generate हो रहा है इधर. ये circuit में what are going to be generated here is you are going to get some, first point, you are going to get some base voltage here. With the help of VCC, you will get some base voltage. That's good. You are getting some base voltage. Because of base voltage, you are getting some base current here. Maybe that base current is very small because we have taken beta value, large values. Current flow rate, but both come flow rate. So where base current is flowing there. Because of base current, you can get here IC current will flow. Because IC is equal to beta times of IB, it will magnify the current. It will become the IC current, output current. Because of this drop, we'll get some voltage here. A VC voltage will create in the DC circuit. देखो each and every parameter क्या क्या कर रहा है उधर. And this IB will multiply with 1 plus beta times that will generate the IE current. And that will create the drop here as emitter voltage. So what the DC circuit is doing is it is creating the currents and voltages in DC analysis. So you are going to get VB, you are going to get VE, you are going to get VC in the DC circuit. We are going to get IB, IE and IC. All these things will come in your transistor biasing circuit. Sir, अभी क्या करना? DC analysis हो गया. अभी AC analysis करने के लिए क्या करना? Means मेरा interest है अभी here signal देने के लिए सोच रहा हूँ because it has to amplify by the transistor. ये already a circuit में DC power is generated. इधर DC power अंदर generate हो गया transistors में. इधर इनपुट पावर है, इधर आउटपुट पावर है, पावर्स जनरेट हो गया, मेरा सिग्नल अंदर भेजना. सपोज बाय चांस, डोंट राइट दिस, आई विल शो यू द मिस्टेक्स व्हाट वी डू. सपोज हियर आई कनेक्टेड ए सिग्नल लाइक दिस. फॉर एग्जांपल डायरेक्टली सिग्नल कनेक्ट किया. क्या मिस्टेक कर रहे हैं आप? मींस इन प्लेस ऑफ VB point, in place of VB point, you are going to get here VIN here. That means forcibly आप क्या किया? बेस वोल्टेज ऑलरेडी जनरेट हो गया उधर. आप क्या कर रहे हैं? बेस वोल्टेज को इनपुट वोल्टेज बना रहे हैं आप. मेरे को दैट इज वेरी बैड इश्यू इन द क्लास. इनपुट वोल्टेज नहीं बनाना. बेस वोल्टेज शुड बी बेस वोल्टेज ओनली देयर. हमको इनपुट वोल्टेज को ऐड करना बेस वोल्टेज से. हमको दोनों को ऐड करने के लिए सोच रहे. आप क्या कर रहे हैं? बेस वोल्टेज को इनपुट वोल्टेज बना रहे आप. मीन्स यू आर ओवरलैपिंग दैट वोल्टेज. बेस वोल्टेज का इंपॉर्टेंस खत्म हो रहे. मेरे को चाहिए बेस वोल्टेज शुड बी देयर बिकॉज डायोड शुड बी ऑन देयर डीसी वाइज. सिग्नल हैज टू बी ऐड विद दैट. सिग्नल ऐड करना होता. तो मेरा DC plus AC, they have to be added, not overlap. So ये concept थोड़ा गलत हो रहा है concept. That's why nobody will give directly a shot to the battery. VB battery को directly shot नहीं देता हूँ मैं. उनके लिए क्या कर सकता हूँ मीन्स, ये आइडिया बहुत खराब लग रहे कॉन्सेप्ट. उनके लिए what this people has done, see here. This is your R1. If I keep suppose one capacitor like this, CC, and I made suppose ground in the lab. First initially my ground किया. This is your base voltage. Correct? आपका base voltage है VB. This base voltage, when you keep a empty capacitor, the capacitor will try to charge the total DC voltage. Now, after some time, you can see what is the voltage across this capacitor is. You will say VB is the voltage. देख सकते हैं अभी? The capacitor, why I connected here means capacitor has to charge the base voltage. For that purpose, I kept the capacitor. Initially, the capacitor is empty, but after some time, it is fully charged to the VB voltage. So it is working, capacitor is working like a DC source. After that, you remove this ground in the lab. A ground को remove करो. Now, if I give some signal here, that is your small signal VIN. कैपेसिटर फुली चार्ज होने के बाद सिग्नल दिया. अभी देख सकते हैं ये डीसी सोर्स है, ये एसी सोर्स है. कैपेसिटर इज बिहेविंग लाइक ए डीसी सोर्स एंड योर सिग्नल इज बिहेविंग लाइक ए एसी सोर्स. इन दोनों को VIN माइनस ऑफ दिस डीसी विल गिव द वोल्टेज अक्रॉस द बेस पॉइंट. अभी ए पॉइंट का वोल्टेज चेंज हो रहा है. ये वोल्टेज क्या हो रहे हैं? VIN माइनस ऑफ माइनस VB. Therefore, a point is becoming now VIN plus VB, it is becoming. So this is the work I have done. My interest is at the base point, input and VB should get added. वो trick my capacitor से किया मैं. So this is the story of a coupling capacitor. The word itself is telling coupling का meaning है DC and AC are getting coupled. That is called coupling capacitor. Coupling capacitor का काम एक ही है, DC AC को add करने के लिए I kept the capacitor. If these two are getting added, because of my signal, some current is going here, small IB. AC current flow हो रहे हैं. ये AC करंट अंदर जाकर कैपिटल IB को ऐड हो जाएगा. So you'll have DC current plus AC current. DC current is represented with capital IB, small IB we represent with AC current. These two currents are added, will get multiplied by beta times, you will get IC plus small IC. Your AC current is also getting amplified by beta times, and here IE plus small IE you are getting, and this voltages will become VC plus V0 and VE plus small VE. Like this you are going to get two voltages in the class, two currents in the diagrams. In your amplifier circuit now, two voltage, two currents will be there. One is AC current, one is DC current, one is AC voltage, one is DC. That means our interest is AC should add with the DC. Therefore, the currents also will get added, they will get amplified by beta times. You will enjoy the amplification for AC signal also. So this is the concept how we applied in the subject. Now my interest is at the output side, I don't want DC, I want only AC output, because when my voice is coming, we don't have any DC. But अंदर जाने के बाद DC ऐड हो गया, मेरे को only AC output चाहिए. उनके लिए क्या कर सकते हैं इधर? At this moment, if I keep a capacitor once again CC to the output V0, आप देख सकते हैं VC plus V0 should not come as an output. Capital VC is the DC, V0 is output AC. मेरे को only AC output चाहिए. Then if you keep the same capacitor here, coupling capacitor का काम क्या है? DC voltage को block करेगा, AC voltage को बाहर send करेगा. So it is going to charge the DC voltage. charge का meaning है it will block the DC voltage. It will just block the DC and it will send the AC output. That means initially AC is adding with DC. Finally, DC is stopped by the capacitor and it is sending the output as AC. So you are getting only your AC output. And you can keep some load here, RL. So this is the way how these two capacitors are working in the concept. One is working like a coupling capacitor. One is working like a decoupling capacitors. Okay. एक coupling capacitor जैसी काम कर रहे हैं, एक decoupling capacitor जैसी काम कर रहे हैं. So now you can write here only in the notes the story of coupling capacitor. CC means here coupling capacitor. Coupling capacitor, which will couple AC with DC. So this is the concept of coupling capacitors. इन दोनों को couple करेगा, AC with DC को couple करेगा. Okay. If you come to this coupling capacitor, we call it as CC means decoupling capacitor बोलते हैं. Decoupling capacitor, which will decouple DC, which will decouple the DC with AC. So just it will decouple the DC from AC. DC from AC you can write. DC from AC. So only you will get the AC output. So that is the reasons we need two capacitors. 100% sure we need these two capacitors in amplifiers. If any one capacitor is missing, what you want you cannot achieve in the class. If I am giving AC, I must get AC output. Okay, AC दे रहे हैं, आपको AC output चाहिए. So you will get the AC output. How these currents are getting amplified? You can see here, this is your IB current. This is your small current, which is IB. This is your AC DC are mixing each other, called superimpose हो गया. So the DC of your small base current is IB current. This is your IB current, which is mixing with the signal. It is getting amplified here as IC. You can see linearly it is getting amplified to IC current. So this is the way how the current is amplifying in transistors. With the help of beta times, it is amplifying here. Okay. So this is the complete concept. But the problem here is the output what you are expecting here, we are getting two types of outputs. One is coming like this, and one more is coming like this. आपको आउटपुट में दो आउटपुट्स मिलेगा, दो चांसेस है मेरे पास. एक आउटपुट स्विंग ज्यादा आ रहे, एक आउटपुट स्विंग कम आ रहे. एक केसेस क्या है, कौन से केसेस में ज्यादा स्विंग आ रहे, कम स्विंग आ रहे. इधर हम RE is not equal to 0 करते आ रहे. Here RE, if you make it 0, we are getting. So there are two issues are going here with emitter resistance in the amplifier. RE resistor का काम क्या है? It is behaving like a negative feedback resistance I told in biasing circuits. For negative feedback resistance, not only in DC analysis, it's working in what I can say in AC analysis also. It is working as a negative feedback. So this resistor is behaving as a negative feedback resistance. Negative feedback. If this resistance behaves like a negative feedback, maybe voltage gain will reduce, because negative feedback always reduces the gains. Gain कम होते आपका signal output कम मिल रहे. तो RE ज्यादा लेते resistor, आपका सिग्नल स्विंग ऑल्सो कम हो रहे. RE वैल्यू 0 करते मीन्स नो नेगेटिव फीडबैक, आपको गेन बहुत ज्यादा आ रहे. दिस इज द स्टोरी ऑफ RE. तो RE का इंपॉर्टेंस क्या है इधर? RE is behaving. RE is a negative feedback resistor. Negative feedback resistor, which reduces the gain, which reduces the voltage gain, which is called AV. RE is a negative feedback resistor which reduces the voltage gain, AV. So if anybody don't want negative feedback effect, you want more output swing. If you want more output swing, suppose in the class, ज़्यादा swing चाहिए आपको, then I think a resistor को हम zero बनाना. A resistor को zero कैसे बना सकते हैं? Means if you take a capacitor parallel to this RE like this, एक capacitor लिया C. So whatever the current you are seeing here, it is coming from the top. This is IE plus small ia. If we keep capacitor CE here, can you see that DC current cannot go to the capacitor because it will work as an open circuit. So it will go to capital RE, which is more important for biasing circuits. Biasing circuits के लिए IE RE से पास होना, that is called biasing analysis. But AC analysis में मेरे को ये RE नहीं चाहिए. RE आते क्या हो रहे, आपको प्रॉब्लम क्रिएट कर रहे, इधर गेन को कम कर रहे. सो गेन को कम कर रहे, गेन को ज्यादा चाहिए, तो ये करंट स्मॉल IE current should not go to RE. That is my interest. Then what I have done is this small IE, I kept a bypass path for it. I just kept a bypass to the AC current. वो करंट क्या करेगा, बाईपास हो जाएगा CE में. Therefore RE का इंपॉर्टेंस खत्म हो जाएगा AC एनालिसिस. तो इन AC एनालिसिस RE का इंपॉर्टेंस नहीं होते if you keep a bypass capacitor. Therefore it will become short circuit when AC analysis comes. CE will make short the RE value, so RE will become 0. So this concept will come when you keep capacitor. Okay, if you don't keep capacitor, this condition will come. So this is called the story of bypass. So I can write here a point. CE means bypass capacitor. CE means bypass capacitor, which will bypass AC current and nullify RE effect. So this is the story of a CE concept. It will just nullify the RE effect. So no feedback effect will come when you take the bypass capacitors. And one more good point you are seeing in the board is your output, you are having 180 degrees phase shift output. Common emitter is the only transistor which will give the gain values as negative values. Because of that, we are getting here 180 degrees phase shift. 180 degrees phase shift. This is a 180 degrees phase shift. What is the reason behind? I'll write here. Common emitter amplifier will always give negative voltage gain. Because of the negative voltage gain, we get the phase shift. Common emitter amplifier will always give negative voltage gain. So output will get 180 degrees phase shift. This point is very important, which is happening in only in common emitter. It's a special property of common emitter systems.